In this lecture, we'll learn how to load and evaluate our LLM model before pruning. We'll use transformers and Hugging Face datasets libraries to load and use our model and dataset. Transformers is a library that provides state-of-the-art LLM models and tools for natural language processing. We'll use transformers to load our LLM model that we fine-tuned for a sentiment analysis task. Sentiment analysis is the task of identifying and extracting the opinion or emotion expressed in a text, such as a positive, negative, or neutral. Hugging Face Datasets is a library that provides easy access to various datasets for natural language processing. We'll use Hugging Face datasets to load our dataset that we used for fine-tuning and evaluating our LLM model. We'll use a dataset called SST2, or Stanford Sentiment Tree Bake 2, which consists of a movie reviews labeled with binary sentiment polarity, either positive or negative. We'll also measure the size of our LLM model before pruning using parameters as the metric. Parameters are the numerical values that define the behavior of the model, such as weights and biases. The number of parameters indicates the complexity and size of the model. To load and evaluate our LLM model before pruning, we need to do the following steps. First, we need to import the Transformers library and the Hugging Face Datasets library. We've already done this in the previous lecture by just running this following code. Then, we load our fine-tuned LLM model and tokenizer from our output directory. We've already done this in the previous lecture by running this code here. Then we load our ST2 dataset from the Hugging Face Datasets library. Again, we've already done this, but the code is here. Once we have everything all preloaded and ready to go, then we pre-process our dataset by using our tokenizer to encode the text and labels into tensors that can be fed into our model. We've already done this again in previous lectures by running this code here. Once we define our training arguments by using the training arguments class from the Transformers library, the training arguments specify various parameters and settings for training and evaluation, such as batch size, learning rate, number of epochs, logging steps, and output directory. We've already done this as well in a previous step in a previous lecture by running this following code as well. But just to reiterate, this will give you essentially everything that you need in order to run and train the model. Once we define our trainer by using the trainer class from the Transformers library, the trainer is a tool that provides a simple and efficient way to train and evaluate LLM models. We'll pass our model, our data set, and our training arguments to our trainer. Once arguments have been passed to the trainer, we evaluate our model by calling the evaluate method of our trainer. This will evaluate our model on the text set of our data set and return a dictionary of metrics, such as accuracy, precision, or recall. We can evaluate our model by running the following code. We can then print the results by using the print function. This will print the results in a readable format. We can print the results just by simply printing results. Then we measured the size of our model by using the numeral method of our model parameters. This will return the number of elements in our model parameters, which indicates the number of parameters in our model. We can measure the size of our model simply by running the following code. And then what this is, you can increase and decrease the number of parameters and then run this to check for the size. You can increase the parameter size very easily just by adding layers. And then generally speaking, most people repeat layers or repeat layers and number of parameters within layers. So if you just add a repeating layer, it's really easy to do. And then if you run this code, then you get an output that would look something like this, which is essentially all of the evaluation metrics from the training process. So as you can see, our fine-tuned LLM model achieved an accuracy of about 92% on the test of the SST2 dataset, which is quite impressive. However, our fine-tuned LLM model also has about 109 million parameters, which is quite large and complex. In this lecture, we learned how to load and evaluate our LLM model before pruning. We learned how to use transformers and Hugging Face dataset libraries to load and use our model and dataset. And then we also learned how to measure the performance and size of our LLM model before pruning. In the next lecture, we'll learn how to prune our LLM model by using PyTorch pruning module. We'll use PyTorch pruning module to apply magnitude pruning to our LLM model by removing some of the weights based on their absolute values. See you in the next lecture.